Yep, testing. Yep. Good. Better. Better? No? Hello? Yes? No? No? No. Look down when I talk. Yeah, I'll talk loudly. Okay, yep. Sound check, yes. Okay, yep. Good afternoon, everyone. My name's Hugh Sanderson. I'm going to be talking about the CPP backend for Haxe. The title Haxe girt by C++. I think the Australians amongst us will recognise the quote. It's from the Australian National Anthem, and it uses the word girt, so you've got to respect that. So you don't see that much these days, so I thought I could use it too. So I'll be covering couple of things. I'll start slow and get boring. I'll talk about the overall architecture, then I'll talk about some gory details and some things you might need to know when you're thinking about implementing things one way or another, and some eye to the future. Why did I create the backend? Well, the original motivation was speed. I tried to do some physics stuff with Nico. It was just too slow. It's fine for certain tasks, but as soon as you need to do any kind of number crunching and looping, it was too slow. So the current state of affairs is that it's probably at least 10 times faster than Nico for the numerical style applications. 2 to 3 times Flash and V8. I guess it's a bit debatable, but I think it's clearly about twice as fast as Flash. And it's not as good as handwritten code, but it's not that far behind. So I call it about half the speed, but again, that's debatable and depends on applications. So the basic architecture starts with the user code in the top left corner there. The .hx files are the ones that you guys write. It then gets combined with these orange HXCPP files, which are from the standard library code. Gets all munched through the Haxe compiler. The bit of interest that I've written is the girt.ml, and it produces this set of outputs: the CPP files, the header files, and the build.xml files. And at this situation, the Haxe compiler's job is done, and it hands the operation over to the HXCPP build tool. Here, the build tool takes in these generated files, adds in some of its own for good measure, and uses a compiler or SDK that you have installed on your machine to produce a native executable. There are also native NDLL files, DLL files, that can be used as runtime. The compiler and the SDKs, obviously we don't provide those, but there are many that we do support, and there are plenty of free ones that you can use to work with the CPP compiler. So the girt.cpp.ml is the bit of code for the CPP specific bit of code inside the Haxe compiler that I've written. It's written in a Hello, yes? Okay, gotta hold it here. Yep, alright. I could sit if you like, if it could be easier. Yep, I'll stand for the moment. Okay, so the back end is implemented in a single file, so that I guess I can keep my damage to a minimum on the other targets. It's about 3,000 lines of camel code, which is getting up there, I guess. Sort of more than you can take in one sitting. And I gained most of my OCaml knowledge from the existing Haxe compiler code, so I've probably got a bit of a French accent if you go through the code. And it's evolved well beyond its initial design, so some of my normally high programming standards may have slipped, just as I had to put a hack upon a hack as things evolved. So the HX library files are the ones that get distributed with the compiler, and they bear a remarkable resemblance to the Nico ones, and that's no coincidence because I copied them, obviously. Actually, with the new announcements today of the unification of the a lot of the libraries in 209, it actually makes a lot of sense that I copied it. So laziness is a virtue in this sense. In this case, I always believe that when I'm a programmer. And what these files mainly do is use various small little delegations to the actual CPP runtime that gets compiled into the final executable. There's not a lot of logic or intelligence in these files. The code generated by the backend is designed to be readable in a CPP sense, which is not to say absolutely readable, but as best we could do, and to have a high correlation to your Haxe code. So if you've written while something, I've tried to write while something. If you've written switch something, I've tried to output switch something. So that you can pretty much follow along, and it's written. There are some things that just don't map to the C compiler, like local functions, don't exist in the standard C version, although C++11 is bringing in some stuff that actually may have fitted in quite well. But to move to that would introduce a whole level of incompatibility with compilers. We're still using some compilers that are 10 years old, so it's going to be a while before we could confidently use any of these new features. So some things like local functions actually come out like a bit of a dog's breakfast. They just little macros and hash if this all over the place, but that's something we'll have to live with. I try to use native facilities wherever possible, so I use native virtual functions, native RTTI, native exceptions. I'm hoping this will make it easier to interop with other libraries as well. I also use templates to do casting, so you can actually quite naturally map something equals something in C++, and if it was like a float int conversion or a downcast or whatever, it will just it'll work according to the C++ rules, pretty much like it works according to the Haxe rules, which keeps the two closer together. I also use a lot of macros for doing some of the slightly unusual stuff, or for doing code positionings and things. And the idea here is that guys like you who want to tinker with some of the aspects of the compiler, it's going to be easier for you to change a macro than it is to change the OCaml code and recompile the OCaml. So I try to have as much kind of accessible, make as few hard decisions as possible in the OCaml code, and leave all the stuff to the CPP code where it's more accessible for tinkering, and patches as well. So I've had quite a few patches come through from people because they've had the ability to go and edit it. So I think this has been quite a good thing, even if you don't like macros. So the runtime files are distributed with the HXCPP Haxe lib, and they provide the basic runtime. So they've got all the facilities, garbage collection, some file AO stuff, threads, strings, arrays. That's all in there, and it all gets compiled by you with your compiler
which is good for debugging, and it's good for if you want to change something, you can put a printf in one of the functions just to see what's going on. So providing it in source form, I think, has been a bit of a win. Of course, every time you create a new CPP project, you have to recompile these files for the new project. Generally, you only have to do this once per project, but it can still be a bit of an overhead. So I've had some ideas with maybe some object caches where if you've compiled the file once with identical compiler settings and identical input files, the output should be identical, and therefore I should be able to cache it. I think GCC may even have some of this stuff in it built in as well, so I might be able to hook into that. But I think the advantages of providing the runtime in source form outweighs the disadvantage of having to compile it for every project. So the runtime DLLs come in binary form, although there is source included if you need to compile them up yourselves. And again, they mirror the Nico ones. And again, it's because I just copied the Nico source code. But I had to change. There are a few differences between the ways HXCPP interacts with external DLLs and the way Nico does. So while I can copy the source code, I still need to recompile them, and I can't just use the Nico binaries. Although the converse is actually true, is you can use CPP compiled DLLs with Nico generally, and that's one thing I do with NME. It's a universal DLL for Nico and CPP. So the build system is responsible for taking all your files and combining them with your compiler or SDK. And generating the executable. So in a lot of ways, it's like a make system or the Ant build system, but because it uses Nico, which is comes with every Haxe install, so I can be pretty sure that no one is going to have to run off and go, oh, well, I need to install Nico now to get this to work. It really limits the dependencies to practically zero, which I think is a good thing. And the whole build system is built around just simply setting variables and conditions, and it's quite easy to hack and quite easy to create a new to configure a target or add a new compile flag. So I think it's been quite a useful contribution to the whole system. Easy enough that we've had other people, particularly Joshua, contribute actual whole back ends, like the BlackBerry and the WebOS, are user submitted contributions, and they're really only 50 lines of code that's pretty easy to read. So if you want to get in and change some compiler settings or make a new compiler, it's actually pretty straightforward. And you can see here, these are the targets that we've successfully compiled to, and it's pretty much anything that has a C compiler we can compile to, or C++ compiler, I should say. The notable exception here, I haven't put the NACL Google native client in, but that's probably on the horizon soonish. So now I'll get into some implementation details, and if you're not technical, you could spend some time, digest your lunch, and I'll get on with the rest of it. So what makes the CPP backend fast is the strong typing. Not as in hitting the keyboard, but so whenever the compiler knows the exact type of the variable that you're using, it can perform the optimizations, it can parallelize them, it can do them out of order, it can use registers, and it just loves it when it knows the exact type of the variable. When it doesn't, which is in Haxe when we have a dynamic variable, you have to look up a variable by name, the performance immediately drops. If we were to use dynamic everywhere, it would be much more like a scripting language and scripting language performance, we'd lose all the advantages. And in this case, laziness is not a virtue, so unfortunately I've had to do some work to get it to be as strongly typed for as long as possible. And knowing where the back end is using strong typing and not using strong typing should give you an idea of what constructs are going to be fast and which one's going to be slow. So just in my discussions, a couple of concepts with the typing. I refer to stuff as dynamic, and in Haxe you can actually have a variable which you just call dynamic. And this is just to say that it's an object that you know nothing about, and you can perform certain operations on these objects, like look up a field by name, and you're just going to get another dynamic out. So the compiler can't really do anything here except look up stuff by name. If it knows the type of a class, and you refer to a variable x of that class, it knows, well, actually it's 14 bytes from the beginning of the structure, bang, it gets it there. If it's dynamic, it's got to go, okay, where's the variable x? It's got to go to a table, find x, and go, oh, okay, now it's 14 bytes. It can carry on. The other concept is boxing, and this happens when a non-class variable must be referred to as dynamic, and the non-class variables there are bool, int, float, string. And in order to treat them as a dynamic, you actually have to allocate off a little dynamic structure just to manage this particular value. And that is the probably biggest problem with the performance. And it's also where you can get some strange things like an array of integers, or sorry, not an array, a list of integers can be slower than a list of other objects. It's because the other objects are already effectively dynamic objects, and the integers you have to actually create a little dynamic to handle them. So that's boxing. Wherever an integer is passed to a dynamic, it will be slow. So where currently is dynamic stuff used? Well, it's used wherever you have a parameterized class, like here, some class t. If the t variables are stored in that class, they really have to be dynamic. There's no other way that I could store both, because t might be an integer one day and it might be a string the next. The common denominator is dynamic, so I have to store the variable in the dynamic. Now Haxe actually has a facility to automatically generate whole new classes from your templated class. So if I go some class integer, it will actually go, I'll make a whole new class called some class integer, not parameterized. And in that case, you're back to full speed again, because it's duplicated the code and made a specific integer version of it. Now, so I've had some ideas here about where performance could perhaps be improved. It might be possible to create up to 4 or 5 instances of the class, rather than one class per type that you use it with, for the particular value types, and therefore have a compromise between having to create a new class for every and have to specialize the template for every type you want. You really only need it to do it for the particular value types, because normal object types are actually pretty much the same speed, because they don't have to be boxed. And then on a slight variation of that is bool, int, and float can all be represented by a float without loss of information. So perhaps I could just have a floating point version of those. The other big one is functions that you store in a variable effectively become dynamic. So when you pass like an integer to one of these functions, it gets passed as a dynamic, again creating all the problems. Now I can't really create a new function class for every different type of function there is, because if you have a function that takes an integer and then one that takes a class A and one that class B, I'd need to have a different type of function for each of these each of these situations, and you'd end up with hundreds of different function types. It might be possible to, for example, do either just float or dynamic, and maybe only up to the first 3 arguments I could make fast, and after that it becomes dynamic variables. So there's another open issue about speed, and you'll particularly notice this in NME with the CFFI, where we make calls into the DLL. They pass in dynamic variables, and immediately if you try to pass an integer in, there'll be a slowdown. When you use this construct here, where you've got use your squiggle brackets to define define a type in a function, I call this, this is a type restriction, so that's saying that bar has this function called run. In this particular case, I may actually be able to create a fake interface and then automatically implement that interface on everything that calls this function, and that would get speed back up to full. And similarly here, the bottom case, we've gone bar that x is 20. That's an anonymous function, and it may be possible to actually create a fake class in this case to hold the x value, and again bring that there up to full speed. So there are some ways where dynamic is being used at the moment that it might be possible to avoid it in the future. Arrays are actually probably the fastest way you can do things. Like if you have to choose between an array and a list in CPP, you should probably choose the array. Lists have the advantage if you're pushing things onto both ends and stuff. But the crossover point where it becomes better to use arrays, it would be quite a large number of elements, or worse to use arrays. This is because the arrays are pretty much optimized and are all fairly strongly typed. When you access an array using brackets I, it does a range check every time you do that. So there's that would why you would be potentially slower than native code, but there are some unsafe get and set functions you can use if you're particularly interested in speed and you know for sure that you won't be running over the bounds of the array. An array dynamic is another interesting one. I actually implement this fully as just a normal dynamic, because even if it is an array of dynamic, then there's a bit of a loss there, because you should actually be able to do full speed things. But if I need to pass in an array of bool to an array of dynamic, there's effectively no common denominator. Well, the common denominator is not easy to use. So I've switched over to array of dynamic. In itself actually will be slow to access. There might be something I can do there with an array base class, but I'm not sure if it'll be worth it in terms of speed. So interfaces, originally I implemented these using the normal C++ multiple inheritance constructs, but they turned out to be really quite painful to work out where objects were being referenced from the garbage collection, because they have offsets to the objects from various places within other objects. And I changed this to a delegation model, and everything was much nicer. So when you create an interface from an object, what it does is it creates a little glue object in between that just passes the function calls onto the real object. So interfaces themselves are now kind of little objects, and that's just made things easier as it's just sort of implementation detail, really. So biggest pain in my proverbial is the C++ order of operations. Haxe has a clearly defined that the operations, particularly like for example function arguments, should be evaluated left to right. So in this case down the bottom here, I've got f of c blah 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 comma I. The expression on the left should be calculated first, and the expression on the right should be calculated second. But C++, trying to be nice to itself, has declined to guarantee the order in which it will evaluate these things. It's mainly because it's trying to optimize for speed, and when things are pushed on the stack, they're usually pushed on right to left, which is the exact opposite of what we want. So there might be some stuff to be able to tease these expressions apart and use temporary variables to calculate some of the partial expressions and then assemble them back together in the correct order. But it's pretty hairy. If you look at this expression here, evaluates I++, which may or may not be 0. If it is 0 and it doesn't enter this bit here, then if I've calculated any of those variables in a temporary variable, then I've wasted the calculation, and not only that, I've increased I, and it will all be wrong subsequently. And similarly with this OR expression here, if the expression on the left evaluates to 0, then it will do the expression on the right, otherwise it won't. So it's an extremely difficult problem, as I think anyone who tries to write a target will understand. Currently this is still effectively a bug in C++, that you have to be careful of the order, that you can't expect the strict left to right ordering. So the foreign function interface has evolved from the Nico one. It's designed to be largely compatible with it, but it also has been designed to be more generic. Dynamic libraries are built, you can build them using whatever you like, but generally the HXCPP build tool is a good choice because it will make sure all your compiler flags and things work correctly. And it allows you to interact effectively using a completely different compiler version, so the API between the two is very simple and makes really no assumptions how the variables are stored. So in this case we can write, for instance, the NME DLL. We can use it for Nico. I had it working with VA and CPP, and potentially any of the other targets can implement the interface. This is also where the boxing issue comes in, because the API effectively involves dynamic variables. You also have to be a little bit careful, because I've been a little bit slack and made the DLL take care of some of the garbage collection and thread management. So you probably have to do a little bit of a read up if you're going to be storing variables for later use, or using multi-threads in your NDLLs. I've also recently added some metadata magic, where you can inject code into your CPP classes, into your functions, into the headers, into the beginning of a function or end of a function. So if you need to just call off, for instance, if you wanted to call printf directly, you could inject the code using a little bit of metadata. And this also lets you, if you need to do some kind of store some additional variable in your class that doesn't really match the Haxe syntax, you can use the metadata to do that as well. So garbage collection, actually, a lot of the performance of the backend will depend on the quality of the garbage collection. Originally I started off with the BOEM GC like Nico does, but I had trouble getting it to run very well on the ARM. And also, as more and more targets come online, you would have to make sure that library was also updated to match the new targets. The current system uses a kind of a homebrew system, and it only uses two assumptions: a standard stack layout, that is, things are pushed on the stack when you call a function, and that you can actually get all the registers to be pushed on the stack if you make a sufficiently complex function call, which is basically a virtual function with a lot of parameters in a different file. And so far so good, that those two assumptions actually have covered all the targets that we've hit so far. So that means that we don't have to do sort of bizarre system headers in order to get the garbage collector to work. It's mostly precise, which means it'll mark variables that it finds on the stack, but normal variables will be marked conservatively. And this allows you to have local variables in a NDLL file, and they'll also be found by the garbage collector. And that's been quite useful. There's a problem, is that each thread that runs through the garbage collector needs to effectively clock in and clock out, so that the other threads don't wait for it when they need to do a collect. The compiler generates code that actually does the marking, so rather than having a data structure that describes how classes are laid out, there's actually a piece of code that it runs, which is pretty simple. And there's the garbage collection, there's plenty of scope for research and doing more work on this, and any improvements should directly be reflected in faster code for everyone. So I don't know if there's someone out there who loves garbage collection and wants to take it on as a project and make it 10 times faster and be a hero, but yeah, that would be nice if someone does. So looking to the future, we can't all be Albert Einstein, so I have to think about it. So obviously I'm supporting Haxe features as Nicholas comes up with them. Add new compilers as required, and then update the old compilers when Apple decide to move their compilers from developer to app or whatever they choose to do, or Google moves their NDKs around, so just keep those up to date. And these performance improvements that I outlined earlier, I'll probably get to those at some stage if I find a particularly bad piece of code that needs speed improvement. The garbage collection, there's actually scope to do, even if your app is single-threaded. Oh, just in time. Yes. It's all over for me. Alright. So, I think I'm on the last slide anyhow. So, the garbage collection and, yep. I think I've gone grey. I think. Oh no, here we go. So I'm on the last slide in here. So and then some other. Oh no, I've got one more slide to go. Zoom out. Bring it down. Something like that, is it? No. Where am I? Oops, didn't want to do that, did I? Go to last slide. I need second last slide. Yeah. Okay. So the other things I need. Ooh, power. Yeah. Yep.
Like that?
There we go. Look at that. Oh, I was on the last slide. Oh no. So yeah. So also I'm looking to do some instrumentation to improve debugging. So actually put stuff in your code to help you either profile or visualize some of the memory allocations and usage, and a graphical view of the memory usage, so you can actually see how the objects are laid out in memory. All that information is there. It's just a question of accessing it. So I've got a little quick demo I can do on that if we've got time. How are we running for time? Yep. All right, so what I'm doing here is I'm starting up a little debug server on the local machine, listening on the local host, and then when I start up the an application that has been compiled with the debug host set, and then it comes back into the debug server, and I can type continue, and then break stops it anywhere. So that's listed. So some basic debug information. Currently, that's all you can do: break, where, and continue. But it should be a logical extension to view object details and local variables and set breakpoints, just like a proper debugger. Yeah. So that's I guess a glimpse of where some of the instrumentation stuff might go. Any questions? Yeah, that's actually in any CPP executable, particularly I guess the idea was for Android. So to actually talk over the Wi-Fi to your computer rather than over ADB. Android is like environment.
For the debugger you saw, like, show us, is it possible to debug this way, like iOS application?
Yes. Yeah. So again, because it uses a socket that it talks over, as long as your iOS device can find your local host, you should be able to do debugging.
On the same Wi-Fi network.
Sorry?
On the same Wi-Fi network.
So, yeah.
It should work.
It should work. Yeah. Yep.
Hello?
Yeah.
Okay. So, about the debug, for example, iOS has the native debugger. Why can't we use that?
Yeah. So the iOS debugger actually is not too bad. You could well use that. I guess this has Android is currently quite tricky to get debugging going. There are some other things which potentially we can do. For instance, examining objects. You have to kind of know what you're doing to explore the objects with C++ because you have to dereference the pointer and then look through the tables. And potentially that could be simplified in the debugger, and the debugger refers to Haxe line numbers rather than CPP line numbers. But yeah, I mean the iOS debugger would be your first step. I would think it's probably obviously more mature and yeah, probably useful. Same with Windows. Visual Studio is pretty good too. So
no, I think it's a great project. I was just asking for because if there was anything that didn't that was lost from using.
yeah, no. In fact, it should even work on a deployed device. Not connected to your dev computer, but you've got to compile with a debug flag on, so it includes all the instrumentation, which isn't going to be great for performance, amongst other things. So yeah, that's probably your reason why you wouldn't just sort of have it on all the time. It's just in a single file in the debug CPP file in the Haxe project, HXCPP project. So there's nothing real magical going on. It's just talking over a socket.
Hi. Does C++ 11 offer any solutions for performance improvement?
Yeah, I'm not sure about performance improvements. It has potential for making the code more readable with some of the Lambda stuff that it's got for closures. But as far as performance goes, I mean, I would still face the decisions about where to use dynamic and stuff, which is really the key to the performance. So I don't think it's going to help that much. It may tidy up some of the code, but performance I wouldn't expect to be significantly different. Unless, of course, they come out with, the new compiler versions come out with new optimizations as well, which are always a free bonus for us.
Okay.
What microphone works, what doesn't. Okay.
test, sound test. Excellent. All right. Perfect.
So if you want to mute it here, and
Okay.
you can put it in there.
Thank you for your patience. Thank you. Okay, hello world. All right, okay. May the force be with you. My name is Robert Felt, and I'm going to be speaking about making games with the inverted game framework, Awesome. Now, to start off with, I'm just interested to do a quick survey. So perhaps you could raise your right arm if you love using Haxe. All right, fairly unanimous. Right arm, now keep your right arm up. All right, left arm up, please, if you love making games. Oh, excellent, excellent. Now, if you haven't put your hands up, you're in the wrong room. Now, today I will be covering and will be using as an example a Lego Star Wars game, which is called Ace Assault Special Edition. So, thank you very much, Lego. Thank you very much, Star Wars. And may I recommend, if you are in a toy purchasing dilemma between buying a Lego Star Wars product versus perhaps a non-Lego Star Wars product, that we elect the Lego Star Wars product. It's a good product. Now, do we all love Lego? Yeah. We do. Excellent. Yeah, wonderful, wonderful product. Great people as well, and they really believe in what they're doing. And what about Star Wars? We're big fans of Star Wars? Totally. It's part of our generation, right? Now, any Jedi Masters amongst us? But don't raise your arm. Raise mine. Okay. Oh, yes. Yes. The Force is strong in this room. The Force. Now, for those non-Star Wars fans, the Force is an energy field created by all living things. It surrounds us, it penetrates us, and it binds the galaxy together. Now, I'm quoting the original Star Wars movie there. And in doing so, perhaps it sounds somewhat ethereal, quasi-religious, metaphysical. Now, are we comfortable with such terms? I think as developers, we instantiate objects, we dispose objects, we use classes and forms, polymorphism. This is the basic stuff to us. So we are very comfortable with ethereal terms. And the Force and concepts about binding our galaxies together is going to be the recurring theme of my presentation today. So I want to talk about abstract language, high-level language in games development, where we can all talk a common language in amongst our team development. Now, a little bit of background about myself is I've been very fortunate enough to be able to work in small digital interactive development teams and have done so for about 15 years. And in building projects with increasingly larger scale and complexity, of course, I've encountered real issues, experience, or in other words, pain. Now, every time I hit pain and end up doing the 120-hour week to fix the pain, I think I should build a tool for next time. And many of the tools that I'm going to be presenting today in Awesome is tools to relieve pain. My own personal experience, I am a technical architect and a games producer, so I like to combine the two. I like to make fun games and worlds, sustainable worlds. And so I always fall back on the computer programming principle of solid. So single responsibility, open for extension, closed for modification, list-off substitution, so I can swap in, hot swap in subclasses. Interface segregation, so always think atomically and small, and dependency inversion. And they've always put me in good stead. So again, a lot of the architectural patterns I'm going to be showing today will be solid. Now, enough talk from me. I'm just going to show you a quick video, and that'll give you an example of the kind of games that have been developed using Awesome. I'm always curious to know if you do see a game that you recognize, just give me a little nod, because I like to know. Sound.
Ultra kill.
Test. Great. Thank you. Yeah, so the pitch. Making games with Awesome needs a bit of a pitch. We need a bit of a background as to why this tool might be useful to you. So, like the beautiful game, I kind of see the pitch being a game of two halves. On the one half, we've got commercials, which is the opportunity, and also the challenges. And on the other side, we've got the technology, which is the solution, and we'll get to that in a second. You might already know the ending to that one. But first off, the commercial. What is a casual game? Now, I remember playing a lot of solitaire in my time, and of course through to Angry Birds down in the bottom right here. A casual game for me is something that I can just quickly dip into or quickly dip out of. It doesn't require a great deal of dedication or conviction. It's very easy to consume, very easy to put down again. It's kind of a change in your brain waves. It's a very disposable kind of game. I liken it actually to a cup of Starbucks coffee. Just habit-forming, pleasant, nice distraction. So just like takeaway coffee, casual games is a big business. And just a couple of years ago, it was worth 6 billion, 200 million players, fairly significant. But in the future, this is where it's getting to. So that's a pretty serious number. I want a slice of that. And I think, can we get a slice of that? We're all perhaps relatively small teams or even individuals. Can we get a slice of that? And the answer is yes, because the majority of games development is actually produced by fairly small teams. So we are in the running for it. But like any size team, you're going to have different opinions and different perspectives on how to develop your game. And this is what the triangle here is to represent. Now, these might be individuals or they might be entire departments. So we've got Lord Vader representing the project manager. And for him, you know a few there. For him, it's all about getting the Emperor's battleship operational. So milestones and releases and burn rates. Yeah. Okay, all valid. Good man. And then General Grievous, the developer. Multiple juggling, lots of lightsaber wielding action. Really interested in the systems and the crunch. Perhaps there's a few General Grievouses here. And of course Leia. She's the artist. It's all about the emotional response, the look and feel, the mood, the narrative arc. And all are important, but do these people generally talk the same language? Not often. So wouldn't it be nice if we could provide them a common language to allow them to all talk together seamlessly? I'm going to just touch on the software pyramid because, again, anybody in kind of advert-game agency work, you're probably very familiar with the pointy end of the pyramid, which is quick response to customer requirements. And often, a list of bullet points can be mistaken for a game design document. If you manage to build those bullet points, it's probably good and well done, but add another layer to it, and the deck of cards could easily slip up. So we all know we need to move down this pyramid because that's where the money is, that's where the stability is. So we want to reuse code as often as possible, stable code. So there was the commercial. And on this side, the technology. Very brief flux capacitor ride. Let's go back in time. Back in 1990, if it wasn't pre-installed on your machine, you had to order it via mail. Not a very quick, speedy industry. So towards the end of the 90s, we were starting to get in-browser gaming going on with Java, direct to Shockwave. Really started to take off. Early 2000s, Flash, ubiquitous player, lots of development going on, really an industry forming there, lots of people entering it and good skills coming up. The glory days of Flash. And of course, modern era, we're seeing a proliferation of technologies, lots of different options, and a lot of emphasis on these platforms here. Now, do we like this proliferation? Not really. The way I see it is, it's like a bunch of ghosts chasing me around my maze. All I want to do is produce my project here. I want to just clear all these points and then move on to the next project. But they're all chasing me and getting in my way and putting me off my productivity. So wouldn't it be nice to be able to consume a power pill and turn the table, chase them away? And that's where Haxe comes in. Beautiful language, strictly typed, wonderful tool. And it comes with batteries included. I'm going to skip through this because you kind of know a lot of this already, but batteries included. We've got a fantastic tool set there to build some really great games. And particular nod to Enemy and Geesh for providing great output to multiple platforms. So together, they combine to create a multi-platform open source programming language, which is wonderful, but I wanted to talk about games. So I want to talk about a game semantic, that top-level abstraction that allows all my team to talk the same language. Now, whenever I'm trying to solve a problem, I like to turn it on its head. Come at it a different way, because I find problems tend to be top-down, whereas solutions tend to be coming up. So I like that. So OR6, the inverted game framework. This is the realization of that pain of solving those problems. So an open source MIT license framework designed to make any genre of game for any platform. Building on top of the hard work done already with Haxe and Enemy and the other Haxe. So I'm going to just take you on a real whirlwind tour of the key components of the framework to explain. So first off, the game is composed of scenes. I have an intro scene, a menu scene, the main game scene, a game over scene. And within those scenes, entities. This is an entity framework. Entity represents a game object and the common interface for any item that wishes to interact with the framework. Entities are hierarchical, so they can have children and parents, and they're also, those children can actually be bound to state. So it's a state-based hierarchical node graph. Each entity is aware of every other entity, which helps a great deal in games development because you can ask for a collection of other types of entities, and allows them to cross-communicate with one another using an observer pattern messaging system. Above the line, we've got the global services. These are the kind of things that the entity want to ask and talk about. So first off, we need assets, so we need to preload them, and sometimes that can be a bit of a pain. So we take care of that out of the tin. And then once they're loaded, they're available in an asset manager. Again, typed, easy access. So across platforms, we're going to grab an asset based upon reference and purpose, rather than based upon what kind of data it contains. Game session. This allows for save game states or high scores. It can be persistent or temporary. You might just want to pass a player's name around between scenes. This would be the space to do it. Audio manager. Multi-channel sound. And a state-based input manager. So instead of listening to key events, mouse events, we actually start to ask, is joypad fire down? Again, talking in that game language. And top-level overlay. This houses the view, with a view scene graph underneath it. Also controls overall pause functions and mute functions and so on. So again, out of the tin. All of these things out of the tin. Everything is spawned from a factory. So that's what gives us the list cost substitution, is that we can swap out. We have a default, but we can override. So if you want a custom overlay, no problem. You just override it in the factory class and it's ready to go. So that gives you your whirlwind tour. Hopefully lots of architectural patterns, so you may be able to see and recognize that. And in doing so, perhaps we can feel the force. Yeah, I touched on those, but oh yeah. So platform independence. I just want to quickly show a sort of semi-technical draw here. Is when we're actually referencing classes, we go into a core alias, which then, via conditional compilation, will send off to a driver-specific package, so either Flash or Enemy, and that can be extended. And that driver package has a concrete implementation, which extends an abstract platform agnostic version, which is implementing another platform agnostic interface. So from a development perspective, you needn't ever worry about the driver state. You don't need to worry about what platform you're actually developing for. It's all taken care of seamlessly. And also, by doing it on a driver basis, we can insert drivers, or you can create a custom driver for your custom project and choose to release that publicly or not release it publicly. It's your choice. So there's the whirlwind tour. Isn't it time to make a game? So I'm going to show you a quick video. I will remember the sound this time, of Ace Assault Special Edition, and try and recognize some of the patterns that we've seen in the architectural diagram. Plan B. Okay. So I'm now going to kind of what's the word? Autopsy that game. So take it in piece by piece, and hopefully be able to recognize each of the different aspects of it and how that relates to the framework, and how we can grow a game like that using the framework. So as I mentioned before, everything comes from the factory. So this really does define our game. It's a data-driven architecture. So everything starts there. We plant a kernel in the ground, and the kernel is the main loop of the game. It handles the update cycles and so on. But it really conceals that from the developer in a facade. From the factory, we're into that preloader. It's grabbing our assets. You may notice that the preloader is animated. Not only is it animated, but it can be interactive. You've got access to all of the managers at this point. So you can even have a game inside the preloader. And this is very important, especially if you've got long loaders and so on. From there, we're into the assets, and then we'll be able to launch into the first scene. And we're talking about scenes, so then the artists, remember, they're talking about this scene, they're talking about the intro scene, as are the developers, as are the project managers. When it's done, the project manager can tell the client this scene is done, and they can go and have a look at it, and it can be a standalone scene in its own right. So that scene, you know, it's using some of the aspects of the framework, the audio manager, you heard the music going on. We had 3D graphics going by, which is Sandy 3D, one of the Haxe libs, and it's wrapped in an entity in that scene. From that, we launch into the game. We're going to see instructions scene. Again, reusing the same entities in a different way in that scene. So we've got reuse. From there, we go into the main game, which is kind of a homage to Space War. star command, 2-player, you against an NPC. You take on the ship and run around, follow them, blast them, use your special weapons until they're destroyed. So, how does this work in terms of composition? What we got here, and this is the hierarchical state machine, and I'll just briefly give an example of a non-player controlled artificial intelligent player. So they start off fairly passively, and so they don't need to do much. They just need to kind of sit there, update the physics, update the view a little bit. And so that's what we've got in the agenda of all. The agenda represents the state name. So we've just got those going on. But then they get shot. So run away. Okay, evade. So add on some more behaviors. Navigate away and deploy some countermeasures. But perhaps they get shot some more. They get aggressive. So let's switch it around. These are still going on, but now we're going to retweak those same components to navigate towards and choose an aggressive weapon. So we're going to reuse entities inside entities bound to agendas using a hierarchical state machine. So lots of reuse of code. Those same behaviors could be applied in different games for different purposes. The benefit of that? Well, you may remember you saw the Asteroids game mode. This was basically for free. This is just the same dumb opponent with no navigation away. Just divide by 2. We saw the boss ship. Again, the same behaviors. Just slow down, fire lots more, and be stronger. We even saw against 2-player opponents. And again, this is one extra line of code. You can have as many ships as you want. So we're really seeing the benefit of code reuse. Once the game is complete, we're back to a menu scene where using the game session, we'll be able to preserve the fact that I was so awesome at number 1 that I got a gold medal, and as a result of that, I've unlocked 2 extra levels. I just work my way through the game, unlocking all golds until I'm all done. Great. So adding more scenes, more levels, more starships is just data. No extra code needed. And in fact, for the 2012 product range, we were able to include 4 extra ships, 8 new levels, and 1 extra game mode for really just creating those assets. So adding more is easy, it's cheap, it's productive, it's good value for everyone, and it's good fun. You can just play around and adapt things. Great. So are we feeling like Jedi Masters? Well, we've seen that casual game industry is big business. We know that. We're interested in that. We've also seen that the next big thing, the next platform, the next target comes along really quite often. It's quite scary and unnerving. There's all those ghosts running around chasing us on the Pac-Man board. We know that Haxe provides a multi-platform engine, and hopefully I've demonstrated today that Awesome provides a multi-game framework. So talking in common language across our games development team, we can increase productivity, we can make games better, and everybody's a winner. So that's how to become a Jedi Master and making these games. Now I just need to do, that's probably the conclusion of my main part of my presentation at this point. So time check. We've got time for the interesting slide. Do we want the interesting slide? All right. Okay, good. So using Awesome today involves, well, need to install Haxe. Need an IDE. Wonderful Flash developer. Then from there, after running a couple of scripts, you can create a new Awesome project. Just double click there, put some names in there, great. Wonderful. At this point, you've got a default factory, override some of this stuff, add in a new scene, add in a new entity, override some of the template class here, and then hit F5. You know, you're building a game within, 15 seconds. And then you just make it better. Tweak it and iterate it until it's done and it's dusted and it's built, which is fine for us developers. Yeah, we're all happy with that as a process, as a work tool, because we're all general grievances. We're all twirling lots of lights. Whereas I want to move it forwards a little bit. I want to de-skill it somewhat. So perhaps the future of Awesome is to host it as a managed service, pop it in the cloud. So how might that look? Perhaps as a subscription service. A development team or an individual developer might subscribe at or6.com, perhaps for free, and then provide an online IDE. with some helpful build tools, maybe asset management or audio tweaking tools or whatever it might be. Perhaps because we're in this to make money, we're in this to do business, we've also got to think about our Lord Vader, is we need some workflow tools. So we want to see some agile tools. Of course, we're going to need an online integrated compiler. And looks like that bit's done. So, wonderful. And then from there, perhaps we can de-skill publishing channels by having a managed service to be able to do that. So you build a game using this tool and publish it and then give back a percentage maybe. Or perhaps we can start to have an entity store. So rather than just selling games, we can sell parts of our games. So our game is composed of many entities. Perhaps some of those, just like on Haxe C, could be of value to other people's games. And so maybe we can offer them out there, either as a fixed rate charge or as a percentage of another project, or for free, whatever it might be. And in turn, creating a nanotransaction cycle. Perhaps there might even be some gold at the end of the rainbow. It would be really wonderful to be able to see games developers being able to make money without actually having to produce a game, but on that recurring value. So there's a possible future for this framework. Great, thank you. And I'd like to special thank you to these people. Any questions? The question was, does the game work with Gish? Does that game work with Gish? Hello. This game was not targeted for Gish. I've not actually done an experiment to see how far it would get with Gish. I'm actually optimistic. I'd like to test it. Perhaps on a simple basis, just try and get one scene working with some 3D models and so on. But the separation of concern is that it's Gish's responsibility to work within its premises. So once it does, then it would work on Gish. And I think Gish is very strong and very exciting. So the
yeah, is it focused, is your
Awesome. The inverted game framework.
Is it focused around the NMA / sort of movie clip approach, or is it flexible enough to cope with the fact that with HTML you may go with a completely different approach?
There is nothing in the framework which mentions a movie clip. There is nothing in the framework that makes any specific requirements on any specific concrete platform. From a tangibility perspective, it's often more efficient to do some magic and target a specific bit in a specific way. Because I love using blend modes a lot. I use a lot of blend modes, and that isn't even going to work particularly well on other platforms. I can't live without blend modes, so hint. So for me, I'm going to be doing a lot of movie clip specific stuff, but there's nothing in the framework which is movie clip specific.
And sort of a different question really, but not my side.
Yeah. I chose Sandy at the time because there were some really good tutorials. It seemed like the most stable of the Haxe 3 libraries at the time that I originally made that selection, which was probably 2.5, 3 years ago. I've stuck with it since, and I really liked it. Any other questions from anybody else?
The elephant in the room, how is 6 sung? How is R6 awesome?
Okay, it's all 6.
No, it's awesome.
Yeah. I just call it the inverted game framework, actually. Yeah.
How do you structure your entities? Are they actually like PBE kind of entity components, where it's very, very loose coupling, or is it strong tight coupling entities? What do these components called? Or entities just game objects?
Entities are game objects now.
So it's inherently based model.
Yes, but the emphasis on the developer is to make those entities as small and as atomic as possible. So it may well simply be a binding for a property to update, or it might be a movement behavior, or it might be something more elaborate. It might be an entire 3D engine. It's your choice as a developer and where you make that separation. Now, personally, I like to use a lot of hybrid. Some things make sense to break down into component behaviors, and other things, they do make sense to be a monolithic, huge class. So I make that choice based on a number of factors, pragmatic factors.
Yeah, I like to compare that.
Yeah. Well, I'd happily show you code from my laptop later on. Yeah. Yep, this has been out since, version 1 was released in January. Prior to that, it's been out probably less stable since for over a year. So go for it. Yeah. Yeah. Any more questions? Can I sit down? Great, thank you.